Log AB is equal to log A plus log B. So we can expand it and write it is in the form log AB. So we are going to write it as log A plus log B. Larger the value of Ka, smaller will be the value of pKa. They are inversely proportional and stronger will be the acid. At equilibrium, the concentration of the reactants will reduce, the concentration of the products will increase, and at a point of time, this will become equal, at which they will attain equilibrium. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today we are back with session 8 of the chapter Equilibrium. So in the last session we studied about ionizations of acids and bases and what is the dissociation constant or ionization constant of an acid, which is Ka, and dissociation constant or ionization constant of a base, Kb, right? And what are polybasic acids and polyacidic bases also, right? And then the different factors affecting acidic strength, as well as what is pH of a solution and pH or pOH of a solution we discussed in the last session. In today's session, we are going to see or we are going to show or derive the equation pH plus pOH is equal to 14. So we have already studied this equation in the last session, that pH plus pOH will be equal to 14. So it is an important question in your examination also. The question will be show that pH plus pOH is equal to 14. So it's a very small derivation which we have to study, which is very important. Also we are going to show that pKa plus pKb will be equal to 14, which will be equal to pKw. And ionization constant for weak electrolytes also we will be studying in this session, and regarding salts and some numericals also. Okay, so let us begin with the first one, that show that pH plus pOH is equal to 14. Okay, so we are going to derive this equation from an equation we already know. Okay, so we already know that molar concentration of H plus into molar concentration of OH minus is equal to 10 to the power minus 14. Where we have studied this ionization product of water we have studied, right? That is Kw is equal to molar concentration of H plus into molar concentration of OH minus, and at 298 Kelvin, what is the value of this? It is equal to 10 to the power minus 14, right? We have already studied this. So we already know this equation, and using this equation we are going to derive pH plus pOH is equal to 14, right? So we already know this equation. Now to this equation we are going to multiply the equation throughout by minus log base 10. Minus log we are going to multiply throughout equation, that is on the reactant as well as product side. So what you will get? Minus log H plus into OH minus. That means in what format it is? Minus log I am going to multiply to H plus and OH minus. So can I tell that this is in the form log AB? Yes, it is log A into B, right? So what is log A into B? It is log A plus log B. So log AB is equal to log A plus log B. So we can expand it and write it is in the form log AB. So we are going to write it as log A plus log B. So you can see here minus log H plus into OH minus. I am going to multiply minus log, and on the other side also I am going to multiply minus log base 10 to the power minus 14. So as I told you, this is in the form of log AB, that is log A into B, which is equal to log A plus log B. So I am going to split and write now. So it is minus log base 10 H plus, right? Okay, what did I multiply here? It is minus log. So that minus sign is also important here. That is why this minus is here. So log A plus minus log base 10 of log B. Okay, so H plus and OH minus separately it comes now. Now on this side, this part, it is in which form? It is log A to the power B. It is log 10 to the power minus 14, right? So it is in the form log A to the power B, which is equal to this, whatever is in the power, it will be written here, and log A. It is in the format B log A. So these two log equations are very important. Log AB is equal to log A plus log B, and log A to the power B is equal to B log A. So these two equations are important. So now we are going to expand this in that format. Log 10 to the power minus 14 will be equal to, yes, this will come down, right? Minus 14 into log 10. Minus 14 into log 10, and already what are we multiplying? It is minus log, right? So that minus will be also here. So I hope it is clear. So now what is left behind? Minus log molar concentration of H plus minus log molar concentration of OH minus is equal to 14. See, minus and minus will become plus. 14 into log base 10 of 10. Log 10, right? So what is log 10 value? The value of log 10 is equal to 1. The value of log 10 is 1. So 14 into 1 is what? 14 itself. Now, this part is clear, that is 14. Now coming to this part, what is minus log base 10 of H plus? We have already studied this. What is the equation for pH? pH is equal to minus log molar concentration of H plus, right? So instead of writing this, can I write it as pH? Right, because both of them are equal. Now what was the equation we studied for POH? That is minus log molar concentration of OH minus. So instead of this one, can I write it as POH? Which will be equal to what? 14. Log 10 is 1, right? So what it is? 14. So this is how you derive this equation. So we showed that pH plus POH is equal to 14. So from where, which equation we started? It is molar concentration of H plus into OH minus is equal to 10 to the power minus 14. So till now we studied what is pH and POH of a solution, and we studied the relationship and the derivation of pH plus POH will give you 14. Now there is another two important concepts that we have to study, that is pKa of a solution and pKb of a solution. So the A stands for acid and the small b stands for base. Okay. So what is pKa of a solution? It is the negative logarithm to the base 10 of ionization constant of weak acid. So we have already studied the equation to calculate ionization constant, which was that it is Ka, right? Ionization constant is Ka. So minus or negative logarithm to the base 10 of the ionization constant of a weak acid is called as pKa. So that means pKa is equal to minus log base 10 of Ka. Ka is the ionization constant of weak acid. So the negative log of that is called as the pKa. So what is the important thing you have to remember? We have already studied that when Ka value is more, okay, when Ka value is more, we can say that the acid is strong, or else we can say that the strength of the acid is more, but it is inversely proportional to the value of pKa. So if the value of Ka is very high, that means that the acid is very strong, and if the value of pKa is very less, we can say that the strength of the acid is very high. So it is inversely proportional. So you can see here, larger the value of Ka, okay, larger the value of Ka, smaller will be the value of pKa. They are inversely proportional, and stronger will be the acid. Okay. So for example, if I am telling you the pKa value is very high, pKa value is very high means the acid will be very weak. And if Ka value is very high means the acid will be stronger. So they are opposite to each other. I hope it is clear. So when Ka is high, acid will be stronger. When pKa is high, acid will be weaker. Okay. So I hope it is clear. Now moving on to pKb of a solution. What will be pKb then? It is the negative logarithm to the base 10 of ionization constant of weak base. That is pKb is equal to minus log base 10 of Kb. It's the same format we are writing here also. Okay. So Kb is ionization constant of weak base. Now larger the value of Kb, smaller will be the value of pKb, and stronger will be the base, and vice versa. That means when Kb value is high, you can say that the base is strong, and when pKb value is high, you can say that the strength of the base is very weak. It's a weak base. Okay. So we can say that they are inversely proportional. When pKb is really high, Kb will be small. Okay. So when Kb is higher, your base will be stronger. So I hope it is clear. Now moving on to the next one. So according to the pKa and pKb, we are going to show that pKa and pKb, the addition of that gives 14, which is equal to pKw. So I hope you remember what is Kw. It is ionization product of water. Okay. So we have already studied a relationship between Ka, Kb and Kw while we were studying about ionization product. So we know that at 298 Kelvin, K into Kb will give you Kw. So this equation we already know. So again, as we have done in the previous equation, we are going to multiply the whole equation, that is on the reactant side as well as product side, by minus log base 10. Okay, so taking minus log base 10 on both sides. In this format also, what it is? It is A into B, right? So if I am going to multiply a log here, minus log of Ka into Kb, right? It is again in the format log AB. So what it is? Log A plus log B. How can you expand it? Log AB is equal to log A plus log B. So what it will be? Minus log Ka plus minus log Kb. So this is how I have to expand it, right? So that is what is written here, minus log Ka into Kb, which is further written as minus log Ka plus minus log Kb. So log AB will be log A plus log B. I hope it is clear. Now moving on to the other side, which is equal to this equation, we are multiplying by minus log 10, right? So minus log of Kw. Now we already know what is the value of Kw at 298 Kelvin ionization product. It is 10 to the power minus 14, right? So we can also write it as minus log 10 to the power minus 14. Now this is in which format? Log A to the power B, which is equal to B log A, right? So what it will be? It will be minus, which was already there, and this minus 14 will come down. Minus 14 into log base 10 of 10. Now what is log 10? It is 1. So this minus and minus will become positive. So you have that here, right? So what will be your final equation? Now what is this? Just now we studied what is pKa. It is minus log of Ka. So you already have minus log of Ka here. So minus log base 10 of Ka is equal to pKa. So instead of writing this, I can write in the place pKa, and this will be equal to pKb, which is equal to 14, and which is also equal to pKw. Right. So I hope it is clear. This is how you derive this equation. So it is very simple as well as very, very important for your examination. Okay. Now moving on to the next one, that is ionization constant for weak electrolytes. Okay, so let's see, we are going to consider a weak electrolyte, which is Ba, and it ionizes partially in water and can be represented as Ba gives B plus and A minus. Okay, so this is your weak electrolyte, which will dissociate into B plus and A minus. It will dissociate, right? It's a weak electrolyte. It will not completely dissociate, but it will partially dissociate into B plus and A minus. Hence, it is partially dissociating means that at the same time when it is getting dissociated, at the same time B plus and A minus will be forming Ba also. So, there exists an ionic equilibrium between them, right? Okay. Now, let C be the initial concentration of Ba, and let alpha be the degree of dissociation, and out of C mole, C alpha mole dissociate to give C alpha mole of B plus and C alpha mole of A minus. Therefore, the remaining concentration of Ba at equilibrium is C minus C alpha moles. So, what does this sentence say? Let us understand this. So, I hope this equilibrium is clear for you. Ba was the weak electrolyte which dissociated into B plus and A minus, right? So, initially, we are taking in two cases. Initially, what is the concentration? Initially, only reactants will be present, right? Products won't be formed. Initially, only the weak electrolytes will be present. Ions won't be there, right? So, we consider that concentration as C. Initially, the concentration of the weak electrolyte Ba, let us consider it as C. So, what will be the concentration of B plus and A minus then? Will there be any concentration? No, right? Initially, before starting the reaction, it will be 0 and this also will be 0. This is initially. Now, at equilibrium, we are going to consider at equilibrium. At equilibrium, what happens? At equilibrium, what happens? We already know that at equilibrium, the concentration of the reactants will reduce, the concentration of the products will increase, and at a point of time, this will become equal, at which they will attain equilibrium. So, we are considering that concentration as C alpha. So, initially, the concentration of Ba was C. So, at equilibrium or to attain equilibrium, some concentration has to be reduced, right? So, that reduced concentration is C alpha. That reduced concentration is C alpha. So, initially it was C. and it reduced by a quantity C alpha. If it has reduced by a quantity C alpha, that exact amount will be increased on the other side, right? Whatever it is reducing on this side will be increased on the other side. That is why they are at equilibrium, right? So whichever quantity is reduced here also C alpha will be the concentration of B plus form, and C alpha will be the concentration of A minus formed. Okay, so initially it was C alpha reduced. So now the concentration is C minus C alpha. Now initially it was 0. How much it has increased now? By C alpha. So I hope till here is clear. C stands for concentration and alpha stands for the degree of dissociation. That means how much extent the dissociation process has taken place. So I hope till here it is clear. Now we are going to apply the law of mass action, which we have already studied. What is the law of mass action? It is the equilibrium constant will be equal to the molar concentration of the product of molar concentration of the products divided by product of molar concentration of the reactants raised to the power which is equal to their stoichiometric coefficient. So in this equation, what are the products? It is the dissociated ions, right? So it is B plus into A minus, molar concentration of B plus into A minus divided by BA. So this law of mass action we have already studied. So now we already know from this equation what are the concentrations, and we are going to substitute here. What is the concentration of B plus at equilibrium? C alpha. What is the concentration of A minus at equilibrium? It is C alpha again. Now what is the concentration of BA at equilibrium? It is C minus C alpha, right? C minus C alpha. So it is C alpha into C alpha divided by C minus C alpha. So what does this part become? 2C and 2 alpha is there. So it is C square alpha square divided by C minus C alpha. Right. Now in this, can I take C as common and put it outside? So what will your equation become? C square alpha square divided by C into 1 minus alpha. From both of this, C is taken as common. Now this C and this C can be cancelled, right? So what it will become? C alpha square by 1 minus alpha. So that is the equation of ionization equation for ionization constant for a weak electrolyte. K will be equal to alpha square C, that is C alpha square by 1 minus alpha. So I hope this is clear for you. Now in the same way we have studied for a weak electrolyte, that is acid. So I hope this equation is clear for you. So now ionization constant of weak electrolytes for weak acids, how it will be? Yes, the equation is Ka. Just now we studied the equation K, right? This is for weak electrolytes in general. For an acid, it will be, the ionization constant will be Ka, which is equal to C alpha square. Ka will be equal to C alpha square by 1 minus alpha. We just now derived this equation. I hope it is clear. Now, as we are considering weak electrolytes means their dissociation will be not up to the mark. Their dissociation will be very less. So in that case, the value of alpha, what is alpha? Degree of dissociation. The degree of dissociation value will be very less. So what will we do is, this 1 minus alpha can be neglected. Okay, as it is a weak electrolyte and its degree of dissociation is very less, 1 minus alpha can be neglected. So Ka will be equal to what then? C alpha square. Okay, Ka will be equal to C alpha square. And what can be alpha? Alpha can be written as Ka by root of Ka by C. So this is the equation for finding the degree of dissociation. So why we are not considering 1 minus alpha? The degree of dissociation value for a weak electrolyte is very less. So we neglect that. So only what is remaining in the equation? Ka is equal to C alpha square. So alpha will be what? It is root of Ka by C. So we also know that concentration is inversely proportional to volume. So we can also write this equation as root of Ka into V. Either way we can write this equation. So what is that you have to remember? The degree of dissociation will be inversely proportional to the concentration and directly proportional to the volume, right? So same way for weak base also the exact same equation is used, that is Kb. Instead of Ka, it will be Kb will be equal to C alpha square by 1 minus alpha. That means the molar concentration of OH minus is equal to root of Kb into C. So the same equation we can apply here also. Kb is equal to C alpha square by 1 minus alpha. Again, as it is a weak electrolyte, we are going to, as it is a weak base, we are going to neglect 1 minus alpha. So Kb will be equal to C alpha square Alpha square will be equal to Kb by C. Hence, alpha will be what? Root of Kb by C. Okay, where Kb is the ionization constant of a base. So, from here we can say that the degree of dissociation is inversely proportional to the concentration. So, I hope this is also clear. Now, moving on to the next important part, that are salts. Okay, so you might be familiar with salts already in your basic 7th standard syllabus also. You know that acids and bases combine to form salt and water, right? So let's see, these are substances which are formed by the combination of acids and bases, right? So generally we can say that acid and base combine to form salt and water, right? So there are 4 types of salts which are going to study here. Okay, so a salt which is formed of strong acid and strong base, like sodium chloride. Okay, one type of salt is which is formed from a strong acid and a strong base. So an example is sodium chloride. So the strong base here is sodium hydroxide. Okay, the strong base is sodium hydroxide and the strong acid is hydrochloric acid, HCl. So the salt formed is sodium chloride and water will be also formed. So sodium chloride is a salt of a strong acid and strong base. So if it is a strong acid and strong base, this salt will be neutral. Okay, the salt will be a neutral salt. So this is what you have to remember. First type is salt of a strong acid and strong base. An example you have to remember, and it is a neutral salt. Coming on to the next one, salt of a strong acid and weak base. So the strong acid again I am going to take here is HCl, which is the strong acid. Now which is a weak base? It is ammonium hydroxide. Ammonium hydroxide and HCl. Ammonium hydroxide is a weak base, HCl is a strong acid. So what is the salt you are going to get? It is NH4Cl and water will be there, right? Ammonium chloride is the salt. So as it is a strong acid and weak base, right? Strong acid and weak base, this salt will be an acidic salt, right? It will be acidic. Acid is stronger, right? So it will be an acidic strong. The first one, both of them are strong, so it will be a neutral salt. Moving on to the next one, salt of weak acid and a strong base. So the weak acid I am going to consider here is acetic acid, CH3COOH, acetic acid or ethanoic acid. And again the strong base you can consider sodium hydroxide. Now what will be the salt form? CH3COONA and water will be formed. So this is a salt of weak acid and strong base. Now you have to tell me what will be the character of this. Yes, this will be a basic salt, right? It is made of a strong base and weak acid. Now the last one is weak acid and weak base. Both are weak. So let's take an example of acetic acid, which is a weak acid, and weak base ammonium hydroxide. So the salt will be CH3COONH4 and what is left behind? H2O, right? So this will be again a neutral. This will be again a neutral salt. So I hope it is clear. These are the 4 salts based on the strength of the acid and base. If both are strong, that is strong acid and strong base, you will get a neutral salt. If it is a weak acid and weak base also, you will get a neutral salt. If it is a strong acid and weak base, you will get an acidic salt. If it is a weak acid and strong base, you will get a basic salt. And one example each of it is clear for you, I guess. Right. Now moving on to the next one, that is hydrolysis of a salt. Okay. So just now we studied salt formation, that is acid and base will combine to form salt and water. Now we are going to see hydrolysis of salt. What does hydrolysis means? Yes, we are going to add water and we are going to break something, right? Hydro stands for water and lysis means breaking. So we are going to break the salt. So on addition of water to salt, it will give back its acids and bases, or else either you are going to get an acidic solution or else you are going to get a basic solution. So let's see. Salt hydrolysis is defined as a reaction in which the cation or anion or both of a salt react with water to produce acidic or basic solution. So in a salt, what is present? The anion will be there, cation will be there, right? Anion is a negatively charged ion, cation is the positively charged ion. So in a salt, either one of them or at times both of them will react with water and will provide an acidic solution or a basic solution. So in the presence of water. So this is called as salt hydrolysis, right? So salts of strong acid and weak base, weak acid and strong base and weak acid and weak base undergoes salt hydrolysis because their solution is either acidic or basic. So apart from strong acid and strong base, which is neutral, all the others will give you an acidic solution or basic solution. So let's take an example, general Ma, which is the salt, okay, which reacts with water and dissociate into M plus and A minus. So how does this give an acidic solution? So which are the anion and cation present here? Cation is M plus, which undergoes hydrolysis to form MOH, and H plus will be released. So a solution which is releasing H plus, right? There is excess of quantity of H plus. Yes, you will get an acidic solution. Right, you will get an acidic solution. Now what else is there? A minus, the another ion of the salt, okay, which undergoes hydrolysis and forms Ha and releases OH minus. So this will be a basic solution. So this is how the anion and cation. So either of this can undergo hydrolysis or both of this can undergo hydrolysis and form an acidic solution and a basic solution. So this is how salt hydrolysis takes place. Okay, so this is the salt which dissociate into M plus and A minus, which undergoes hydrolysis to form acidic and basic solution. So I hope it is clear. So now moving on to the next part, that is pH of a solution. There is an equation which relates pH of a solution and pKa and pKb, right? So the equation is very important. pH is equal to 7 plus half of pKa minus pKb. Now if pKa value is greater than pKb, pH will be greater than 7 and the solution will be basic. So we already know that when pKa value is more means that the acid will be very weak, right? Ka should be high, then acid will be strong. If pKa is high means the acid is weak. So if pKa is greater than pKb, pH will be more than 7. So if pH is more than 7, we know that it is going to be a basic solution, right? And if pKa is less than pKb, that is pKb is more means, yes, your base will be very weak. So that means pH will be less than 7 and the solution will be acidic. Okay. So this equation is important which relates pH, pKb and pKa. And when pKa is more than pKb, which type of solution you will get, and if pKa is greater than pKb, what solution you will get, you have to be clear with it. So next class we are going to study about buffer solution and the different types of buffer solution. So I hope the concepts that we have covered in this session is clear for you. So that's all for today. Thank you.